Assalamualaikum warahmatullahi wabarakatuh. I am Nur Saada binti Muhammad Ali from Center for Foundation Studies at IUM. I am representing my team to present our research project entitled Cellulose Agri-Waste for Potential Biopackaging. So million tons of food and materials get spoiled because of storage and transportation issues due to the packaging system inequalities. Over a period, the packaging industry has evolved using modern technology from the conventional methods of new generation packaging, including glass, wood, and paper, to most new biodegradable materials. Thus, it is our interest to develop a new class of materials that can contribute towards the advancement of eco-friendly and sustainable materials for packaging applications with enhanced barrier, thermomechanical, improved rheological, and has antibacterial properties. As for the novelty, sustainable is one of the key considerations while developing a new class materials. This present work uses biodegradable polymer films from renewable sources that are abundant in nature, namely carboxymethylcellulose, or abbreviated as CMC, in order to replace the synthetic packaging films and shed some light towards the advancement of food packaging material. And this is parallel to the National Green Technology Policy by the Government of Malaysia on the alternatives to solve environmental issues through green technology and sustainable materials. The purpose of food packaging is to protect the food and preserve it from undesirable chemical and atmospheric environments. Most of the polymers used for food packaging is derived from petroleum sources, which could affect the environment, health, and economical issues. Thus, the use of CMC in this research work can be regarded as a new revolutionary in the food packaging industry due to the following advantages. 1. It is non-toxic and natural. CMC provides a safe and healthy solution for packaging industry. 2. It is biodegradable. CMC is produced from agri-waste or plant derivative products. 3. It could reduce waste. Since the material used are cellulose-based, that is the most abundant in nature. And last but not least, it promotes green technology, because CMC does not release harmful toxins or polluting the ecosystem. Therefore, in this research work, the objective is, number 1, to prepare biodegradable film based on carboxymethylcellulose CMC and polyvinyl alcohol PVA using economic technique. Number 2 is to evaluate the suitability and compatibility of the novel biodegradable film for food packaging application. Here is the research methodology. So here is the research findings. CMC PVA biofilm was characterized via FTR analysis, SRD, and SEM analysis for the evaluation of chemical properties, structural properties, and surface morphology. Further testing was done in order to study on the suitability of the CMC PVA biofilms as food packaging. We start with the FTIR analysis. The importance of the infrared spectroscopy technique is that it is able to describe the structural configuration and conformation of polymers to elucidate the complexation within the biopolymer blend system. Figure 1 demonstrates the FTIR spectra of the pure PVA, pure CMC, and the CMC PVA biofilm. The spectrum of pure PVA exhibited the main features of the PVA polymer chain that was given by the appearance of the vibration carbon skeleton motion found in the range of 1089 and 1376 wave number. Meanwhile, the spectrum of pure CMC revealed the occurrence of 5 absorption bands that correspond to the signature peaks of the CMC. And apparently, for the spectrum of CMC PVA biofilm, there are 2 new shoulder peaks that appear at the wave number 844 and 1737, corresponding to the vibration motion of stretching carbon single bond carbon and carbon single bond oxygen of PVA respectively, suggesting the success of blending the CMC and PVA together. Next, we have the SRD and SEM analysis. In this present work, molecular modification of the polymer blend into amorphous character is essential in the flexibility improvement for food packaging. Thus, here is the result of SRD and SEM analysis. Figure 2 presents the SRD spectra for pure CMC, pure PVA, and the CMC PVA biofilm. Notably, the spectra of pure CMC and pure PVA show semi-crystalline properties due to the presence of crystalline and amorphous nature. However, upon blending, the peak becomes broadened and flattened, indicating more amorphous properties, which is promising properties in the food packaging application. Whereas, the inside figure shows the SEM image of the surface of the CMC PVA biofilm at 25 micrometer resolution. And in this resolution, a constant microstructure of the polymer blend system shows no phase segregation, suggesting an amorphous nature. And this is water content analysis. Figure 4 presents the water content analysis for tomatoes at controlled environment, in polyethylene plastic, and in the CMC PVA biofilm respectively. Based on this analysis, water content of tomatoes packed with polyethylene is the highest and become unfavorable because the moisture could affect the quality of food. According to the literature, CMC PVA act as moisture absorbers. That's why the water content in container packed with CMC PVA biofilm is relatively lower than in polyethylene. A study conducted by Ottoni et al. 2016 revealed that the low water content could reduce the risk of microbial contamination while preserving the sensorial characteristic of the packed food. And last but not least is on the suitability test. Different fruit and vegetables were packed in a container at 3 different environments. The first one is the control, where we expose the food at open atmospheric environment. Second, the food was covered with CMC PVA biofilm. And the third, the food was covered with polyethylene plastic, and all of them were left at room temperature. It was observed that the samples packed with the CMC PVA biofilm demonstrates better freshness after 10 weeks. And this might be due to the characteristic of the CMC PVA biofilm that have excellent air permeability and breathability. And it was confirmed by the water content analysis previously, where food packed with CMC PVA has lower water content than those packed with polyethylene plastic. And on top of that, the presence of water vapor and formation of moldy in the container wrapped with polyethylene plastic supports our claim. Considering all results, it is suggested that the CMC PVA biofilm can be used for food packaging. As for the commercialization, CMC PVA biofilm packaging is the future in the food packaging industry for high-value added food products, owing to the following features. Number 1, sustainable biomaterials. Number 2, it could maintain structural integrity. 3, allow controlled respiration. And 4, it can prevent microbial spoilage. We have now come to the conclusion, in which CMC PVA was regarded as a potent material in food packaging application, owing to the biocompatibility, biodegradability, and sustainability. The analysis from the FTIR, SRD, and SEM indicates the success of blending the 2 polymers CMC and PVA with enhanced properties that is suitable for food packaging application. Moreover, the suitability test revealed that the samples packed with biofilm demonstrate better freshness and lower moisture content as compared to that of control and container with synthetic polymer that use polyethylene. Thus, CMC PVA used in this present work have potentials to replace current synthetic plastic and can be commercialized in the market of environmental friendly of food packaging. And here is a list of publication and recognition that is related to this research work. And that's all from me. Thank you. Assalamualaikum.